Okay, so how do we combine rational functions? So we're going to look at like adding fractions with polynomials. And we have to remember that if there's no common denominator, we got to go through the steps of factoring the denominators, figuring out what their least common denominator is, and then once we know that, you take a fraction and you multiply both the numerator and the denominator by whatever is missing from the LCD. Okay, whenever we have a common denominator, we can just, by the rules of fractions, we can just add the numerators together and keep the denominator the same. So across the top, 2 plus 1 is 3 over 3x squared. And then we can simplify, because this 3 divides this 3. So this is 1 over x squared. So whenever we have a common denominator, it's not too challenging. You just get to go straight into it. Okay, whenever we don't have common denominators, we have to figure out what each of these fractions needs from the other to have a least common denominator. So if I'm looking at 5 over 4x, so I just need to concentrate on this 4x and 2x squared. So first in the numbers, 4 and 2, 4 has a 2 already inside of it, right? 4 is made up of 2 times 2, so it doesn't need the 2, but it is missing an x, because this is x squared and this is just an x. So I'm going to have to multiply both the numerator and the denominator by x. And you see, I'm not changing anything because x over x is just 1. Right, so I'm just multiplying by a clever form of 1. Now, the other fraction, 2x squared, for it to make the least common denominator 4x times x, so 4x squared, it has to get multiplied by 2 over 2. So now, over here I have 5x over 4x squared plus 2x over 4x squared. 5x plus 2x is 7x over 4x squared. Since these are monomials, the x's can cancel. So this x cancels one of these x's. 7 over 4 doesn't reduce, so I have 7 over 4x. Okay, whenever we have to factor the denominators, though, it can get a little bit trickier. Like x over 3x squared plus 3x plus 7 over 9x squared. So I look at this problem and I think, okay, x over 3x squared plus 3x. Those have a 3x in common. And I'd be left over with x plus 1 whenever I factor out that 3x. Plus 7 over 9x squared. Okay, so 3x and x plus 1, each of these things is a separate term. 3x, x plus 1, okay? We have to have each of these pieces in 9x squared. And everything over here in 9x squared needs to be in this denominator as well. So for 3x times x plus 1, what does 9x squared have that this doesn't? Yeah, it doesn't have, it's not 9. So how can I make this 3 into a 9? I know I'm going to have to multiply by 3. Okay? Now this is an x squared, whereas this is just an x. Okay? Because this x plus 1 is a different thing. So I'm also going to have to multiply it by x. So over here I multiply the numerator and the denominator by 3x. Now, in this denominator, this 3x times 3x, that's the 9x squared. The only thing left over is this x plus 1. So this fraction gets multiplied by x plus 1 over x plus 1. Now you could actually split this up like that. Then it's easier to see that you need to distribute the 7. Okay. So now I have 3x times x is 3x squared over 9x squared times x plus 1 plus 7 times x is 7x, and then distribute the 7 to the 1 as well, so 7 over 9x squared times x plus 1. Now that they have the same denominator, we can combine the numerators. 3x squared plus 7x plus 7 all over 9x squared times x plus 1. We would check the numerator to see if we could factor it, but in this case you can't. So I'm done. Subtraction. Whenever you are subtracting these rational functions, you can change this into an addition problem as long as you change everything in the numerator of whatever's being subtracted. Okay? In this case we only have that 5, but you have to remember to change everything in the numerator. So I'm going to change this to an addition problem by making this addition and then changing the sign of that 5. And now we can just go about the problem. So I have x over x squared minus x minus 12. This factors how? We need two numbers that multiply to negative 12 and add to negative 1. That's right. So x minus 4 times x plus 3. Plus, I'm going to leave myself some room because I know I'm about to multiply the numerator and the denominator. Plus negative 5 over the only thing that 12x and negative 48 have in common is 12. So 12 times x minus 4. So I look at my denominators. I go, okay, x minus 4 is already in both denominators. This denominator has an x plus 3, but it doesn't have this 12. So I'm going to have to multiply this by 12 over 12. And this denominator, what is it missing that this denominator has? X plus 3. So I have to multiply by x plus 3 over x plus 3. Alright, we already know that the denominators are going to combine, so I'm going to go ahead and write this as one fraction. So over here on the left I have 12 times x is 12x. And on the right I have negative 5 times x plus 3, so minus 5x minus 15 all over 12 times x minus 4 times x plus 3. I combine like terms in the numerator. I have 7x minus 15 over 12 times x minus 4 times x plus 3. Okay, now we have complex fractions, fractions within fractions. For this we're going to take care of the numerator, take care of the denominator, and once we've simplified those, then we'll figure it out from there. Okay, so this 4 plus 1 over x, what is that 4 missing that this 1 over x has? It needs an x in its denominator so it can combine. So I'm going to multiply this by x over x. And in the denominator, we see 3 plus 2 over x squared. This 3 needs an x squared if it's going to attach. So I multiply by x squared over x squared. Okay, so now I have 4x plus 1 over x. All right, so I went ahead and skipped a step. I knew that their denominators were both going to be x, so I just went ahead and multiplied and added. So 4x plus 1 over x over, these are going to have a common of x squared, so 3 times x squared is 3x squared plus 2. Okay, so now that we have a fraction divided by a fraction, we take this denominator and we're just going to flip it and multiply it by the numerator. So this is the same thing as 4x plus 1 over x times x squared over 3x squared plus 2. Because these things are being multiplied, I can look for things that can cancel. I see this x will cancel one of these x's. So now I have 4x plus 1 times x over 1 times 3x squared plus 2. So this comes out to 4x squared, because this x is distributed to both, plus x over 3x squared plus 2. Of course, I would check and see if I could cancel anything else, but I can't. All right, and that's how we will combine rational functions.